This is the 7-4 notes. Your objective is that you can solve polynomial equations in factored form. So in exercises 1 through 6, we're going to be solving these equations. We're going to be using what's called the zero product property. Zero product property. And the big idea with the zero product property is that anything times 0 times 0 is 0. And so we're going to be utilizing this to help us kind of figure out some of these solutions for these equations that we're about to get into. And so using this, our goal is to make 0 as many times as we can, just because whenever we multiply by 0, we get 0. And so let's kind of start getting into this. So for number 1, I have x minus 5. And this is in what we call factored. So this is in factored form because everything is kind of as basic as it can kind of get while we still get the correct answer. So for number 1, what we're looking for is we're looking for what's the value of x. And we actually wind up having two values for x, and we'll kind of see why here in a second. The big idea is we want to use this zero product property to make the kind of the parentheses or the x's or kind of whatever it is, we want to make some part of it 0, specifically between multiplication location spots. So we have x times, in parentheses, this x minus 5. And so I want to make the x on the outside, I want to make it so that everything equals 0, and then I want to make it so when I do plug something in for the x on the inside, I make 0. And so what I get on this is I actually can separate these into two different equations. I can separate this into x equals 0 and x minus 5 equals 0. And so this one's already done because we had x by itself. But this x minus 5 equals 0, I add 5 to both sides and I get x equals 5. And kind of the way that this works is, okay, if I plug in, let's say 0, so I go 0 times 0 minus 5, and I need that equals 0, I get, okay, 0 minus 5 is 0, or is negative 5, but 0 times anything is 0, so 0 equals 0. Alright, how about 5 though? Well, when I do 5 times 5 minus 5, that needs to equal 0, so 5 times 5 minus 5 is 0, needs to equal 0, and 0 equals 0. And so that's what we're looking for in each one of these. In number 2, I have 6d d plus 8 equals 0. So again, this is kind of, this one seems a little tricky just because we have like this number out here. Maybe it's because this is a plus instead of a minus, but the same kind of rules apply. So I can go 6d equals 0 and d plus 6 equals 0. And I can evaluate both these. So I would divide both sides by 6, and I get d equals 0. I subtract 6 from both sides, and I get d equals negative 6. And so my two answers are d equals 0, and actually, I guess, reality, you should put these from least to small, or least to greatest, so negative 6, comma, 0. And you can go in and you can check these if you wanted to. Alright, so number 3, I have negative 3t, t plus 7 equals 0. And so I separate these, so I get negative 3t equals 0, and t plus 7 equals 0. So I get t equals 0 because I divide both sides by negative 3, and I get t equals negative 7 because I subtract 7 from both sides. So my answer is t equals negative 7, comma, 0. Number 4. Number 4 is a little different. We have y minus 10 squared equals 0. Alright, well this one looks a little bit different, doesn't it? It has this squared on this, and what does that really mean? Well, that squared really means that we have y minus 10 times y minus, not equals, y minus 10. That's what squared means, is you just multiply the thing by itself. So we multiply y minus 10 by y minus 10. If I set these both equal to 0, I get that y equals 10 and that y equals 10. And so my answer is just y equals 10. I only write it down once. All right, let's look at number 5. Number 5, I have t plus 4, t minus 5. All right, this one looks a little more complex, right? But the same kind of thing happens, is we want to make kind of each individual area. So, this one, maybe change this color. This one, and this one. We want to make them all 0. And how do we do that? Well, we could go t equals 0, t plus 4 equals 0, and t minus 5 equals 0. And we solve for each one. And we get, okay, t equals 0, t equals negative 4, t equals 5. And so my answer, t equals negative 4, 0, and 5. Number 6. We have 7u, u minus 9, 2u minus 5. Alright, this one's a little more complex, but we're still going to use the same ideas. We go, okay, 7u needs to equal 0, u minus 9 equals 0, and 2u minus 5 equals 0. Alright, this one obviously is 0. This one is 9. This one's a little harder though. And so we need to kind of follow that breakdown method. So we go, okay, I'm going to add 5 to both sides. So I get 2u equals 5. And then I divide both sides by 2. And I get u equals 5 over 2. And just leave this as a fraction. This makes life easier. So whenever we do this, we get u equals 0, 5 over 2, and 9. In exercises 7 and 8, find the x-coordinate points where the graph crosses the x-axis. We're given the equation y equals x minus 5 and x plus 5. This is number 7. So, looking at this, I go, okay, not y equals. I need to get this so I find out where they cross the x-axis, which is when y equals 0 equals x minus 5, x plus 5. And that's the big kind of thing here, is the x-axis is when y is 0. These are going to be what we call our x-intercepts. So from this, we get x minus 5 equals 0, and x plus 5 equals 0, and so we get x equals 5, and x equals negative 5. So I would write this out, x equals negative 5, comma 5. If we wanted these in an ordered pair, we go negative 5, comma 0, and 5, comma 0. Alright, number 8, we're given the equation y equals x minus 2, x plus 4. From there, I'm fighting when it's on the x-axis, so when y is 0. And so I have x minus 2 equals 0, and x plus 4 equals 0. So x equals 2, and x equals negative 4. Alright. In exercises 9 through 11, we're going to factor the polynomial. What we're looking for is the greatest common factor, or GCF, greatest common factor. Maybe I'm going to write that out, greatest common factor. What the greatest common factor is what is a factor that both like kind of all things or all terms or two sets of numbers or more, two or more sets of numbers have in common. And if you don't quite remember what a factor is, if I have the number 6, its factors are 1 and 6, 2 and 3. If it's 8, its factors are, and actually that's not this looks like a factor tree. There we go. 8's factors are 1 and 8, 2 and 4, and that's it. I'm trying to think of one that has more. Let's see, 12, 1 and 12, 2 and 6, 3 and 4. And so if I was told, okay, I want you to find the greatest common factor of these, I go, what's the biggest number all of these have in common? They all have 2 in common, so the greatest common factor is 2. And what we're going to do is we're going to kind of exploit that idea in order to make it work. If you haven't seen this before, this is called a factor tree. This can be very helpful for this. Let's take, for example, 12, because we know those ones already. 12 can be broken down into 2 and 6, which can be broken down into 2 and 3. And you can kind of multiply these around, and you can find each of these values that are available for it. All right, so let's look at number 9. Number 9, we're given 4t squared plus 12t. Now, whenever we're looking for this, we're looking for things that they have in common. And so a thing that these have in common, and I kind of just noticed right off the bat, is I say, hey, both of these have a t. All right, so what happens when they both have a t? I kind of take a t out of everything, so I go 4t squared turns into 4t, 12t just turns into 12. Because if I multiplied this t, I'd have 4t squared plus 12t. All right, so that's how that works out. All right, is there anything I can go into both 4 and 12? Yeah, 4. And so I can divide by 4. But I can't just make that 4 disappear. It comes out front. So I get 4t is t plus 3. And just like I did above, you can actually check this. You can go, okay, 4 times t is 4t squared, and 4 times 3 is 12t. And so it's the exact same. Okay. All right, let's look at number 10. If I have 10 k to the third minus 15 k squared. All right, what do these both have in common? They both have k, and they have k up to the second power. And so I get k to the second power. And it has to apply to everything. So if I had some other stuff on here that didn't have k, then this wouldn't work, but it does, so it does. And so I get 10 minus 10k minus 15. And I say, okay, is there anything that both 10 and 15 have in common? Yeah, they both have 5. 5 can go into both of these. And so I have 5k squared 2k minus 3. Now, what I find a lot of times is that students will get hung up right here. They're going to stop and be like, man, I don't know what 10 and 15 have. I don't know what the biggest one that they have in common is. And that's okay. Start with something that you know they both have in common. If this was 20 and 25, I'd still say something like, or maybe not 25, maybe like 26. I'd start with, hey, they both have 2. And I'd start to go from there. And you just keep going until you take everything that they have in common out. All right, number 11. If I have 8x cubed minus 20x squared. All right, first thing I notice is they both have x, and they both have x all the way up to 2. So I'm going to take out x squared. So I get 8x minus 20. All right, I'm not sure what 8 and 20 have in common, so I know they both have 2, so I'm going to go 2x squared. That leaves me with 4x minus 10. Does anything go with both 4 and 10? Yeah, another 2. So I multiply this 2 out here, so I get, not 2, 4. 4x squared leaves me with 2x minus 5. All right, does 2 and 5 have anything in common? No, just 1. And so now I could, if I wanted to, I could go back and I could distribute this and I'd wind up with 8x cubed minus 20x squared. That's my check. And so this is my final answer. Alright, now what we're going to do is we're going to take these kind of two things that we worked on for between numbers 1 and 6 and 9 and 11, and we're going to combine them. So I'm left with, so if I start with 3t squared minus t equals 0. I go, okay, what do these terms have in common? Well, they both have a t, so I'm going to take out a t, and so that leaves me with 3t minus 1, and that gives me 0. And so now I'm kind of going back to what I did for 1 through 6, saying, okay, what goes in for t? Alright, so I have t equals 0, and I have 3t minus 1 equals 0, so that one's obviously done. Add 1 to both sides, so I got 3t equals 1, divide by t, or 3, so I get t equals 1 over 3. Okay. And so my answers are t equals 0, comma, 1 over 3. Let's look at number 13. Number 13, I have 5y squared plus 10y equals 0. Now, in 9, 10, and 11, I kind of always did the y's first, but in this case, I actually see the number that goes into both of these right off the bat. And so I can actually do that in that first step. I can take out 5y. And so what that does is that leaves me with y plus 2. And if you don't see that, that's fine. You can definitely start by taking out the y's and saying, hey, what do 5 and 10 have in common? And you get the same answer. Now I'm going to separate these, so 5y equals 0, and y plus 2 equals 0. So I get y equaling 0, and y equaling negative 2. So my answer is y equals negative 2, comma 0. Number 14. 21n plus 12n squared equals 0. Now, nothing says that you have to have it in standard form. It might be a little helpful. If it is, you could rewrite it as 12n squared plus 21n equals 0. It really doesn't make any difference. First thing I see is I see that they both have an n in common. So I go, okay, n, alright, 12n plus 21. Is there anything that both 12 and 21 have in common? Besides 1, 1 works, 2 does not, 3 does. Okay, so let's just pull out a 3. So I get 3n, leaves me with 4n plus 7. That equals 0. Alright, so I get 3n equals 0, and 4n plus 7 equals 0. So n equals 0, 4n equals negative 7, n equals negative 7 over 4. Alright, so n equals negative 7 over 4, comma 0. Alright. Let's keep going. Number 15 asks us to describe and correct the error in solving the equation. So this person decided to go 15t squared plus 5t equals 0. They factored out 5t. That left them with 3t. That equals 0. So they said, okay, 5t equals 0. 3t equals 0. So t equals 0. And t equals 0. Where'd they mess up? Well, where they messed up was right here. When they pulled out that 5t, they should have left with 3t plus 1. Now this is a pretty common mistake whenever you kind of divide out that 5t. Alright, number 16. The height of a jumping frog can be modeled by y equals negative 16x squared plus 4x, where x is time. Since the frog jumped from the ground, find the roots of the equation when y equals 0. And explain what the roots mean in this situation. All right. So, what we want to find out is when does y equal 0? And so we got 0 equals negative 16x squared plus 4x. Looking at this, I'm going to factor it out. So, okay, these both have an x, and actually 4 goes into both these. So I'm going to factor out 4x. And so that leaves me with negative 4x plus 1. Yeah. Alright, now I can split this up, so I get 4x equals 0, and negative 4x plus 1 equals 0. So I get x equals 0, and let's see, negative 4x equals negative 1, x equals 1 over 4. So my x values are 0 and 1 over 4. And so these are the roots. These are also what you might consider to be the x-intercepts. And what do they mean? And so x is time, and actually it's in seconds. And what this means is that the frog left the ground at 0 seconds and landed at 1 over 4 seconds. So after a quarter second, maybe not seconds, yeah. Okay. And so that's kind of this in context. All right, that's everything. Go ahead and check with your teacher on what your assignment is. Have a good one.